Here we go. We have two types of machine, particularly one of AC type and another of DC type. If we go in DC, we have two things, that is one is motor and another is generator. I have used here only one diagram for both motor and generator. You can note one thing, that the designer who designed the machine actually don't know that it, the machine is designed whether going to be a DC motor or DC generator. I mean to say that constructionally motor and generator is exactly same for DC type. But if we can go in AC, motor, generator and transformer, three things exist. You can note here that the transformer do not exist in a DC type. For DC to DC conversion, we will use a different interconnection of switch that is not exactly as transformer but do the similar things. Talking about AC machine, we have motor, generator and transformer. Motor itself is of two types, like induction type and synchronous type. Generator can also be of two type, like induction and synchronous, but we widely use synchronous type generator. But talking about the AC motor, we use both induction type and synchronous type. But the synchronous type is widely used in industries only, not in our home use, like in our household use. We, we all are aware of the transformer and its working. A transformer is a machine which convert AC of some particular frequency of and particular voltage to another voltage at the same frequency. You can note here that frequency is same at input as well as output, but the voltage is differ from input and output. This is the brief introduction of machine. Talking about DC machine, I have told you that DC machine, generator as well as motor are constructionally same. So I'm using the term machine other than motor or generator. If we talk about types of DC machine, then it is of some types, like first separately excited. The talking about construction of DC machine, we will have two winding. One is for field generation, another is for armature. There are many ways to provide the voltage to the DC field winding, and based on these ways we are classifying the types of DC machine. Here you can see that a separate DC source is used for field magnet and a separate DC source is used for armature. This is called as separately excited. I mean to say that a separate source is used here. Here, the second one, you can see that a same source which is provided at the armature is used for field winding. And you can note one more thing, that the shunt field winding and that armature both are in parallel. But going about the next series excited DC machine, here the field winding is in series with the armature. That's why this name comes, series excited. And here you can say shunt excited, because the field winding is in parallel, it's shunted across the armature. And you can also think there is a possibility of interconnection of both the series and shunt, and there are, and the names come is compound excited. Here we go. Compound excited DC machine. You can see there is a two different connection of compound excited DC machine. First one is a shunt magnet coil is parallel to the armature, and thereafter we have a series winding. And in the long shunt, that is in the right side, you can see that shunt is across the series as well as armature. Here, hence the name is long shunt. Long shunt because both are in series, the series field winding as well as armature, and across that this shunt is there. You can remember this as because two are in series and thereafter this shunt is in parallel. That's why it is long shunt. But in short shunt, the shunt is across only armature. That's why it is short shunt. You can take it like this. Here we have summary of all the different types of DC machine. Separately excited, shunt excited, series excited. In compound, we have two types, short shunt and long shunt. In compound itself, we have two more possibility. That is, if we have, let's go back to the last page. If you can see that we have two winding in both the connection of long shunt or short shunt. If the two fields are additive in nature, I mean both are in same direction, then it is called as cumulative compound. But suppose a case where the shunt field is producing some positive field and series field is negating it, then it is called as differentially excited. That's what the name. Cumulative compound means both the field will add together. Differentially compound means both the field will opposite to each other, and net magnetic field will reduce in differentially compound. Whereas in cumulative compound, net magnetic field will increase due to both the coil